Hey there, super scientists. Man, it was fun talking with you last class about our ice melting experiment, the one where we melted ice on carpet and on tinfoil at the same time, and we saw what melted faster. And we started to talk about, if you remember, we started to talk about like an explanation for that question and how we can figure out an explanation for that question. And that's really what science is all about, is trying to we observe things, we do experiments, and we try to come up with answers for like what's happening in our world. So we didn't quite get to that. I told you guys you were going to be designing your own experiment having to do with ice melting, but we didn't quite get to the end of that. So I'm giving you your homework. This video is explaining your homework for making your own ice melting investigation experiment. And it's going to be practice. You're going to be doing something related to melting ice. It's practice for when you're going to come up with your very own, completely your own experiment. It can be about whatever topic you want. It doesn't have to be for ice for the science fair. And we're practicing the process of scientific inquiry that you're going to be doing in the science fair and just in life. So let's get started. I want to explain how you're going to be making your experiment and how you're going to be figuring out what it is, what your questions are, and all that kind of thing. So if you go to your student corner, hopefully you've been there recently, maybe you got here from Google Classroom, then you should see a new piece of homework, your very own ice melting experiment. You click on that, it'll take you to this page. There's this video at the top, which might have a slightly different picture on it. That's this video that you're watching right now. So you'll watch that. Or you are already watching that. That's explaining the experiment. Scroll down, there's another video to remind you of what we did last time. And then there's all of your homework instructions right here with the questions that you're going to answer. This is a lot, so I'm going to take you through the whole process in this video. So you don't have to necessarily even read very much at all, because I'm going to be explaining it in this video right now. This same stuff is right here in this document. If you click on this, it'll take you to this Google document. So you can, for your homework, either print out this Google form, this document, this Google document, and just write in all your answers on that, and take a picture of it and email it to me. You can even turn it in Lauren Eden if you prefer doing that rather than taking a picture. And that's how you can turn the assignment to me. You also might see there's question 1, there's question 2, there's question 3, there's question 4. What you can do is you can just write down, like question 1 right here, write down the answer to it. Question 2, write down the answer to it, and then just turn in that piece of paper to me, or you could do this as an email. There's also a link to a Flipgrid. You don't have to write anything. You can answer. You can say in your Flipgrid video, this is question number 1. My answer is this. You don't have to write anything, and here's the link to the Flipgrid right here. You just go right there, log in with Google. But I know that some students are getting tired of doing so many Flipgrid assignments, so that's why I wanted to give you the option of doing this worksheet. Okay, if you have any questions about this, basically I've just talked through all this part of the worksheet. If you have any questions, send me an email, and I can help you figure out what to do, as always. Here is my email, guys, right here. If you have trouble writing emails, ask your parents, ask your teacher. It's a really important skill. I can help you with that too, but you might need to write me an email for me to help you. So I just want to remind ourselves, we started talking about this new experiment last class, but I want to remind ourselves what we were talking about. Remember, we talked about the cycle of scientific inquiry, the scientific inquiry cycle. How you start by observing, asking questions, hypothesizing, experimenting, collecting data, analyzing that data, and asking questions again. That's what this whole process is going to be about, is going through this cycle to figure out how the world works. So where we're starting, as we always do, is we're starting with some observations. For our new experiment, the prior observations that we have are the observations from when we melted ice on carpet and on ice cubes at the same time. So let's take a look. A sixth grader named Vea, you probably know her. She made a really great video showing what happened. I just want to really quickly watch that video. You can click on this link to watch that video to remind ourselves about what had happened when we put ice on carpet and on tinfoil at the same time. We watched this video during last class as well. So go to the start of the video. You can see, okay, ice cubes are the same size. She put them on at the same time, and then she waited and see what happened. She sped up this video, and you can see, oh my God, look at that. The ice is melting on the tinfoil so much faster than on the carpet. Look at that. The ice already melted on the tinfoil, and it's still going on the carpet. It'll take another 10 seconds for the ice to completely melt on the carpet. Okay, so you can watch the rest of that on your own. But going back to our worksheet, I'm just going to this part, the same document over here, okay? The first question is reminding ourselves what we observed, and I'm going to give you the answer to that question right now. You probably already know it. Let's read that question together. What did you observe during the last experiment when you put ice on carpet and tinfoil at the same time? Okay, so then your answer is, when I put the ice and carpet on the tinfoil at the same time, I observed. What did you observe? Right, let me write that out, and then you guys can do that. You can write out the same thing if you want, or say the same thing on a Flipgrid. I observed the ice melted faster on the foil than the carpet. Okay. Next question. What do you wonder after the last experiment? We were doing this last class. You guys came up with your questions, so you probably have already done this. A lot of this homework is going to be really easy for you guys. So you have some wonderings that you wonder about. Maybe you're wondering, why did the ice melt faster on the carpet? Faster on the foil than on the carpet. That's a pretty good wonder. Okay, so you'll write out what you were wondering there. You can ask more than one question. You can wonder more than one thing. Questioning can be lots of questions. The next part, though, is asking you to make your question, whatever you were wondering. Let's say, I wonder why the ice melted faster on the foil than the carpet. In the next question, you're trying to make that original question investigable. You want to make an investigative question. We talked about an investigative question last class. The question I just wrote in there is not investigative because I can't really do an experiment with that question. Let me give you an example. This is the same example I gave during class last time of an investigative versus a non-investigative question. This question is a really great question. This wondering is a really great wondering. But your question needs to be something that you can do an experiment with. So as a completely different example, maybe you ask the wonderful question, why is it that things fall when you drop them? Why is it that things fall when you drop them? Why is it when I drop something, like say I drop this Rubik's Cube, it falls? Well, that's not really a question I can answer necessarily. Why does something fall when you drop it? There's no experiment I can do to answer that question. but I can turn it into an investigable question. And that's what your guys' big task for this homework is, to turn your questions into investigable questions. So what I could ask is, what happens? What happens when I drop this Rubik's Cube? And look, I can do that experiment. I can drop the Rubik's Cube, see what happens. Look, it fell. Now, the thing about that investigable question, what happens when I drop the Rubik's Cube, I think we all kind of knew the answer to that question. We all knew it was going to fall. So a really good investigable question is actually one that you don't know the answer to, that will help you answer your main question. So maybe a better question that I could ask is, what will fall faster, Rubik's Cube or this like little eggplant that is my cat's toy? Okay, maybe make a prediction really fast. What will fall faster? You're making a hypothesis. I think that the Rubik's Cube will fall faster. Right, I'm going to drop them both on the count of 3. 3, 2, 1. Oh, interesting. What did you notice? What were the results? I kind of thought that they were going to fall at the same time. Really good investigable questions are things you can do with materials that you have. So I could have asked the question, what will happen if I drop this Rubik's Cube into a pit full of lava? But I don't have any lava around me. There's no hot lava here. So that's not actually a very good investigable question because I don't have the materials. You do have a lot of materials, though, that you can use in whatever question you come up with related to ice melting in your science kit. So use those materials to answer an investigable question that you're interested in. Okay? And this investigable question should be something related to the ice melting, related to ice melting on the foil faster than the carpet. Let me give you some examples that some students came up with during class. So, some students were wondering, does the ice melt faster on the tinfoil than on the carpet because the tinfoil is thinner than the carpet? So then you can come up, so maybe you ask an investigable question, if I put ice on other thin things, like paper, and other thick things, like, I don't know, a book, or a pillow, will it melt faster on the thick thing than on the thin thing? Or some people were thinking, well, and then doing that question, asking that question, it leads to an experiment. You can actually do that, you can actually figure out the answer to that question by doing an experiment. Or you can ask the question, if I turn off the lights, will the ice still melt faster in the foil? And maybe you ask that question because you're wondering, okay, look at how shiny this foil is. Maybe that's what causes the ice to melt faster. Or you could try putting ice on different objects. Like some people were thinking about the fact that the foil is metal and the carpet isn't metal. So like you could try putting, does the ice melt faster on all metal? So you could put it on different metals or on different kind of fuzzy things or on rough things. You are going to come up with the question that you think is most interesting. But the question should be something that you can do an experiment with. Okay, this is the hardest part of this science activity, of this science homework, is coming up with a good investigable question. So if you're struggling with this part, that's okay. You can always try and ask me to help you figure it out, and I can help you. Okay, but so an example of an investigable question, like we were talking about, my investigable question could be, and you could right here, does ice melt faster on wood than on a piece of paper? Does the ice melt faster on styrofoam? I'm just grabbing things out of the kit. Than on an aluminum can. So you could use those, you could steal from me and use those as your investigable question. Whatever your question is, The next thing you're going to do is come up with a hypothesis, which is another word for a prediction. You're going to say, I think that when let's say you put ice on styrofoam and the tin can at the same time, and you're going to say what you think is going to melt faster. Next part, collect data. Basically, you're just going to say what happened after you do your experiment. Oh wait, before that, you're going to do the experiment. No question for that, just do it. That's the funnest part, is you get to actually see what happens. And then you're going to say what happened during your experiment. You could do like what Vea did, which is make a video or take pictures, or you could just explain what happens. Either way. You're almost done at this point. If we remind ourselves about our cycle of inquiry, you've observed from the previous experiment, asked a question, made a hypothesis, experimented, collected data, said what happened. Now you're going to analyze what happened. And what that means is trying to come up with an explanation for why what you saw happened. So if the ice melted faster on one of these than the other one, you're going to say why you think that happened. And then you're going to come up with a new question based off of what you saw. So now that once you've done your experiment, thought about what happened, okay, it melted on this, I think it faster on this, I think that's because of whatever reason, maybe what is the next question to try and prove that? Or to try and, what else are you wondering about now related to ice melting? And then you can just keep on going around the cycle. This is optional. You could do another experiment to try and figure out what else happened. You just keep on going around and around. That's what science is about. It's about exploring. It's about figuring out the world. I am very, very excited to see what experiments you come up with. If you have any trouble with any of this, send me an email. Okay, let me know. And I'm here to help. If you don't want to write this down, you can always do the Flipgrid. Go ahead and look through the Stewart Science page. It'll have all the links. And enjoy it. Have fun. You guys are great. And I'm excited to see what you come up with. Okay, bye.